We're back. We're going to take a look at Lord Rutherford, excuse me, today. So Rutherford did a very, very important experiment. It's often called the gold foil experiment. Now, what he basically did, he had this lead box. Let's see. Lead box. Here's a nice little lead box right there. Looks more like a canister, but whatever. I'm not sure exactly what it was. But inside this thing, he had alpha particles. Now, what did he know about alpha particles? He knew they were big. They had a fair amount of mass, compared to electrons and stuff like that. And he knew that they were positively charged. Okay, so he's got all these positively charged alpha particles, and they're going to come shooting out of this thing, and they're going to shoot at whatever you put in front of him. Well, he put gold foil, thus the name gold foil experiment, but he put a very, very, very thin sheet of gold foil in front of it, and these alpha particles that were positively charged, most of them went right on through. Now, how did he know that? He surrounded it with phosphorus all the way around. Now the cool thing is, whenever an alpha particle hits phosphorus, it makes a flash. So Lord Rutherford, I don't know, maybe he didn't have a life or something, but he just looked at flashes, see where these things are flashing. Now, the results of his experiment are amazing because 9,999 went straight on through. Only 1 out of 10,000 would ricochet off and go somewhere else. Okay, so almost all of these alpha particles went through. That's pretty cool. Only 1 out of 10,000 would ricochet off. So that 1 out of 10,000 must have hit something fairly solid in there. Okay? So that's his experiment. We're going to go ahead and take a look. Results 1 out of 10,000 alpha particles, which remember, alpha particles are positively charged. Only 1 out of 10,000 deflected off. All right, so we're going to look at his 3 conclusions. He was a smart guy. He came up with 3 conclusions from this. First thing he said, atoms have a small positive nucleus. All right. Well, let's take a look at why it was small. We got alpha particles coming in. The picture is down here if you want to see it. I'm going to draw it as well up here. You have alpha particles coming in. Well, what if all the nuclei are big? Is this alpha particle going to get through? And the answer is no, it's not going to get through. It would be like a student going up against, I would say, the Lions defensive line, but any student could run right through that right now. So we're just going to say the Broncos, my favorite football team. Student going up against the Broncos defensive line. Those are big guys, and they're going to stop that student cold. But if the nucleus is small, here's a nice little alpha particle. If the nucleus is small, there's going to be plenty of room for that alpha particle to get right through. And just like we saw, almost all of the alpha particles got through, 9,999. He also said, though, that the nucleus is positively charged. Now we have to ask ourselves a question, how did he figure out that the nucleus is positively charged? Well, once again, the answer lies in the alpha particle. Here comes an alpha particle. Here's a nucleus right here. Now this is the 1 out of 10,000, the 1 out of 10,000 that actually hit, the 1 out of 10,000 alpha particles that hit right on that tiny, tiny little nucleus. Now, imagine the nucleus was negatively charged. Would this alpha particle bounce off? Well, no. We know that opposites attract. That means that if this alpha particle here hit a negatively charged nucleus, it would be love at first sight. They would end up sticking at each other, and I mean, it would not have ricocheted off, but it did ricochet off, and that tells us that the nucleus has to be positively charged, cannot be negatively charged. Okay. In the next video, we're going to take a look at Rutherford. We're going to take a look at his next 2 conclusions.